All right, welcome. We are going to go over this classwork, taking limits directly and using some properties of limits. So first off, want to go over how to evaluate these. These we can do by direct substitution or just finding them directly. So if you could just plug in this value, then you're allowed to do that. The cases where you can't are where you have something that ends up being 0 over 0. We would say that's indeterminate, and we would have to solve something like that either algebraically or graphically. Or we might have some other number over 0, and that we would usually have to look at the graph in order to understand what the limit is. But today we're doing these by direct substitution. So if we're allowed to plug in, we go ahead and we try to do that. So the first one here, this reads the limit as x approaches -2 of x minus 4. So x minus 4, that's a linear function. And we can just plug in the -2 in there for x. And we end up with -6. Okay, the second one, we're taking the limit as x goes to -1, or x approaches -1, of x squared minus 4x. This is a quadratic. So shouldn't be any problems there. We can plug in the -1. We're going to square it. -4 times -1. We show our work, and that comes out to 5. So lots of times when we're evaluating a limit, we're going to get an actual number. Number 3 reads the limit as x goes to -3 of negative square root of -x plus 1. So again, we can do this by direct substitution. We got negative, square root, negative, put in a -3 here, and simplify that. The opposite of -3 would be 3. 3 plus 1 is 4. Square root of 4 is 2, so we end up with -2. Number 4, the limit as x goes to 1 of x plus 8 over x squared plus 4x plus 3. This is a rational function, but when we check, can we plug 1 into the top? We don't get 0. Can we plug 1 into the bottom? Yep, and we're not going to get 0 there. So we're going to do that. 1 plus 8, 1 squared plus 4 times 1 plus 3. And what does that come out to? 9 on top, and 4 times 1 is 4, plus 1 is 5, plus 3 is 8. End up with the fraction 9/8. Number 5, we get to some trig functions. The limit as x goes to pi over 2 of cosine of x. So cosine, again, is continuous. It's defined everywhere. Might have to go back to your unit circle. So do you remember what cosine of pi over 2 is? Unit circle says pi over 2 is going to be up there. And that point right there is 0, 1. Cosine gives you the x coordinate, so cosine of pi over 2 is going to be 0. Number 6, you're taking the limit as x approaches pi of 6. And you might be thinking, okay, what kind of function is this? This is just 6 here. That's a constant, right? Think about what a constant looks like. X equals 6. That means it's a horizontal line up here at 6. Over here is pi. When we get closer to pi from the left or to the right, what's the y value going to be? It's going to be 6. So when you're taking the limit of a constant, it's not going to change. 7, 8, got some more trig functions here. Number 7, as x goes to 3 pi over 4, we want cosine squared of x. So this one we're going to take cosine of 3 pi over 4. We're going to take the cosine of that, and we are going to square it. So the cosine of 3 pi over 4, again, refer to your unit circle. 3 pi over 4 is going to be over there, making a reference angle of pi over 4. Think about what the cosine would be. It would be negative, because we're on the left side, square root of 2 over 2. We are going to then square that. And If you square that, you're going to end up with a positive 1/2. And number 8, last one in this set, the limit as x goes to pi over 3 of 4 sine squared of x plus 1. And again, sine is well defined and continuous. We're going to take the sine of pi over 3, we're going to square that, multiply by 4, add 1 to it. So we should be able to do this no problem just by plugging it in. Pi over 3 plus 1. So we get 4. And sine of pi over 3. Again, go back to the unit circle. Oops. Make this look more like pi over 3. Pi over 3 is the same as 60 degrees. So think about your 30, 60, 90 triangle. Sine is going to be the y-coordinate of that. It's going to be pretty high. That's got a value of the square root of 3 over 2. You take the sine of pi over 3. And then we are going to square that. Multiply by 4, add 1 to it, and then take the square root of it. Of course, you could also do this with a calculator, but I like showing all my work here by hand. This is going to come out to 3 over 4. When you square it, multiply by 4, add 1 to it. So 3/4 times 4 is going to be 3. 3 plus 1 is 4. Square root of 4 is 2. So all that comes out to a nice looking 2. All right, the bottom section. For this, you're going to have to use the properties of limits. And so, properties of limits, I gave you a list there. It's in the PowerPoint, and it's on the Google Classroom. Basically, they say we can multiply by a scalar. You can add limits together. You can subtract. You can multiply two limits together. You can divide as long as the bottom's not 0. You can raise to a power, and you can take a root of it, a radical. So the first one here is going to use the scalar, or the constant multiple. So basically, we can use our properties and rewrite this. First thing we should notice is that the limit as x goes to 4 of f is 4. The limit as x goes to 4 of g is equal to 2. And the limit as x goes to 4 of h is 6. So we're going to use this information to answer these questions. So if I would change these numbers, it would change all these problems here. Now when we're doing limits, I'm going to use the property. I'm going to write these out. So this scalar at 2, we can bring it out in front. So I can write this as 2 times the limit as x goes to 4 of f. So that's the same as 2 times, well, we know what this limit is, right? Because it tells us up here. The limit as x goes to 4 of f is equal to 4. So this whole part here is going to become a 4. So we end up with 8. Here we have one limit, but inside we have a sum of two functions. So we can write that as the sum of two limits. That's the sum of the limit of f plus 1 of g. So we can break it up. And again, we know the first one, that's going to be 4. Plus, we know the limit of g as x goes to 4, that's equal to 2. So we end up with 6. Now we are multiplying, and my worksheet should have had another parentheses around this, so it's clear that I'm taking the limit of this whole product and not just the limit of the first one. So I want the limit of f of x as x goes to 4. So we can write this as a product of two limits. Here's f, here is g. Then we can evaluate them. We know what this one comes out to. That one comes out to 4. Bam. We know what this one comes out to. That one comes out to 2. 4 times 2 equals 8. Number 12, we are dividing. So again, we have a limit of a quotient. We can write that as a quotient of two limits. So we can split it up. The limit of f over the limit of g. Again, we're using f and g here. Oh, sorry, f and h. change that. Caught that just in time. So we take the limit of f over the limit of h. So f gives us 4 on top. H comes out to 6. Simplifies to 2/3. 13. The limit as x goes to 4 of h of x squared. So we are squaring this function. The limit of h is defined. So we can just find the limit first and then square that value. The limit of h, if we look up here, is 6. So this is 36. And the last one. Now it's using a bunch of them. It's using addition, subtraction, scalar multiplication, division. We can break this up. And instead of writing this all out here, I think I'm just going to substitute. So we know what the limit is as x goes to 4 of g. G is 2. So we have 2 times 2 plus f. The limit of f is 4 over 5 times the limit as x goes to 4 of h is 6 minus 6. Simplify that. What do we get on top? 2 times 2 plus 4 is 8. What do we get on the bottom? 30 minus 6 is 24. Simplify down to 1/3. And there you go. We just completed our classwork taking limits directly and using the properties. If you have any questions, just let me know. Bye.